Let's talk about the most extreme pressure experiments on Earth. Physicists are doing these high-pressure experiments for a lot of reasons, but a big one is that they're trying to understand what's going on inside super-Earths, giant rocky planets orbiting around other stars. Human beings are pretty good at creating extreme pressures. The most extreme pressures we create are inside nuclear bombs, but those aren't really very useful as scientific experiments because the pressures last very briefly and we have no way of observing them as they happen. So if you want to actually do an experiment on high pressures, you have a couple different options. For a long time, the big one has been to take two pointed diamonds and crush them against each other in a vise. This is called a diamond anvil cell device. And these are pretty good for getting to some pretty extreme pressures, and as physicists have improved on the technology of making the diamonds, they've gotten even higher pressures in recent years. However, to model the kinds of pressures that you're going to find inside the core of a super-Earth, you need to get beyond what any diamond can accomplish, to pressures where the diamonds themselves would shatter. So there are a couple different ways of doing this, but the big one, the one where the most exciting experiments are starting to happen, are dynamic experiments involving lasers. And the way these work are the researchers take a very small sample of whatever they're trying to crush, maybe a bit of iron, maybe a bit of rock, and they put it just on a table, just a normal surface, and then they take a really powerful laser and they blast the sample with the laser. And the laser, light doesn't create that much pressure, but what it does do is it causes the surface of the sample to turn into plasma and start flying off. And the idea is, according to Tom Duffy, who's a physicist at Princeton University who does these kinds of experiments, you irradiate a sample with a very high-powered laser and you rapidly heat the surface of that sample and you blow off a plasma. And the effect of that plasma, he said, is basically like a rocket engine. As the plasma shoots off in one direction, a wave of pressure shoots through the sample. And we're talking about a wave of pressure that only lasts for an order of nanoseconds before shattering the sample. But in that brief time, as the sample is compressed by that pressure wave, the physicists can see how dense it becomes just by observing it, and then they can hit it with X-rays that actually can reveal to the physicists what kind of unusual chemical structures emerge under those extreme pressures. And the goal here is that once you understand how these chemicals behave at the pressures that exist inside super-Earths and other kinds of exoplanets, you're actually going to learn a lot about how those exoplanets behave. Because, as Duffy explained, at those pressures, the chemicals are just going to behave entirely differently. And there's so much of them that how the chemical structures are behaving is going to affect the behavior of the whole planet. Whether it has a magma ocean or a cold surface, whether it's huge or really compressed and dense, whether it has magnetic fields to keep away radiation. All of these things turn out to be really important to all kinds of features of the planet, including whether it might be able to support life.